Hello everyone and welcome back to Technically Unsure, where I'm not really sure what I'm doing technically.
What am I doing?
So today in this video, we are going to take a look at a mini computer from MinisForum. It's specifically MinisForum NAB9 Plus, as you might have seen in the video title. They kind of managed to put in there an Intel Core i9-12900HK. It's 14 core CPU. It comes with 20 threads. Base clock is 2.9 gigahertz and boosts up to 5 gigahertz. And it comes with 24 megabyte cache. So it's a very powerful CPU basically in there. From what I saw in the specs page, it seems like it comes with a USB 4 and OCuLink port, so you can connect an external GPU to it as well. Seems like the chip's nominal TDP is 45 watt, but if you spike it, use every single core and thread in it, it can go up to 65 watts. That being said, it also comes with an Intel integrated graphics, a 96 execution unit, 1.45 gigahertz, that matters. It can do 4K streaming and some light gaming basically. You can do that. I'm sure it can manage a lot of games in 1080p, but yeah, we're gonna put everything to test. So let me show you. This is the computer that I was talking about. So I told them I really don't need RAM and storage, but seems like they sent one with some storage or some RAM. Doesn't matter, but it seems like it can support up to 64 gigabyte DDR4 RAM. There are 2 slots, so each can do that. So see, yeah, they sent one with 32 gigabyte memory and 1 terabyte storage. Since it's DDR4, I should have a lot of DDR4 RAMs. I'm going to install a bigger one. Let's see what they have sent. So first impression, I was expecting it to be heavier. It's very lightweight, which is awesome. The proper way of opening this is, I think, brute force like that. I've seen many other computers like that. You can basically pop out and see inside. I love it. So easily you can replace the RAM and the NVMe SSD. So this is what they shipped it with. It comes with a very cute little heatsink with a fan for your NVMe SSD. That obviously I'm going to replace 1 terabyte. I think it comes with. I'm going to replace it with something else. And it comes with 2 Wuposit. I think I've seen in some other mini computers that comes with this RAM. So they put 2 16 gigabyte DDR4 3200 RAM. I'm going to upgrade that to something a little bit more powerful because I want to run some LLMs on this and show you guys the performance of LLMs on this. So in terms of I/O, basically these two are USB 3.2 Gen 2 Type A ports. This is a 3.5 millimeter audio jack. Obviously, this is the power button, and this one is the reset for CMOS, so it will clear up the CMOS. This is a DMIC button, and just this side there's just a slot for the heat to dissipate basically, and on the back that's where the magic is. So you have 2.5 gigabit Ethernet, you have a display port, you have an HDMI port, and you have a USB-C port right over here, an OCuLink port right over here, power jack, DC 19 volt, and 2 USB 2.0 Type A. So you can connect your mouse and keyboard over here. Amazing stuff. First, I'm going to show you and run a bunch of tests as is on some games and everything. LLM games, operating system support, Windows, Linux, Proxmox, whatever. And then I'm going to plug in OCuLink and try to get an external GPU to work and then see the performance. Let's keep finishing up unboxing and then I will set things up and show you guys what's happening. All right, so this is the power adapter. Very nice. They ship with HDMI cable. I'm not gonna need it. And VESA mount. As I said, initial impression, it's lightweight, so you can very easily mount this behind your monitor. You will forget about it. So yeah, this is the Mickey Mouse power connector. Basically, it goes right over there. Okay, and input is 100 to 240, basically everywhere in the world, and output is 19 volt, 6.32 amps. Okay, 120 watts. That's max. That is supports. And this one is actually the SATA. You can connect. Basically, it turns into this and you plug it in there and it gives you power and data connection. So this one goes right over there. Okay, should we try this as well? Why not? Hold on, why there is a glue around it? Do you guys see that? Yeah, there is some glue, I guess, to hold that in place. securely. That was easy. So that's how you install it, and it gives you SATA. But where are you going to store the disk? That's up to you to decide. I mean, you can lay it over here with some shielding, maybe, or leave it outside the case, I guess. So yeah, there's a plug, which we are going to test. So I'm going to just connect some SATA disk and see how it does. But before that, I'm going to replace the NVMe SSD and replace the RAM with something higher. I will see what I have and then prepare everything, and we take it for a spin. Give me a couple of minutes. I will be right back. Okay, so we are back. What I did was set everything up, and I ran a bunch of tests in Windows. So as you can see on my screen, I have the pass mark rating of 5167, and if we want to break down into details, the details are here. And if we go to the CPU mark, you'll see that it is 19,000, 2D mark, 3D mark, memory mark, and disk mark. And that's just the pass mark rating. I just wanted to show you guys. Here is the CPU Z score. We are here very close to the others that you can see, but I always take these with grain of salt. I don't know what's going on with CPU Z scores, but it is what it is. And then if we go to the CPU Z, you can see that this is the score. And I want to show you, CPU Z is not really pushing it too far, but I'm going to show you how it does. So when you turn it on, as you can see, power consumption goes to like 80 watts. Okay, honestly, when I was doing some other tests, it was going higher, so like 90, but yeah, CPU Z pushes it to around what you see, it's 80 something, right? So yeah, that's also CPU Z. And I know you guys want me to walk through these tabs in CPU Z, so here they are. Here's the main board, here's the memory, here's SPD and graphics. And let's keep going. Crystal disk mark, as you can see, this is literally capped on my NVMe SSD. So the CPU and the bandwidth and everything for the GPCIe lane is all perfect. This is the cap, what I can get from my NVMe SSD. Okay, so here is the 3D mark score. 3D mark score is 4,372, and I ran it like 2 times, and I kind of always get the same number. So this is what you will get. So yeah, those are the scores for various tests that I did in Windows. Everything is working fine, perfectly fine in here. I've been using it, going around, installing apps, moving around. Everything is so smooth, and you can see the temperatures and everything. One thing I want to show you, I'm going to stop talking and I want you to see the base, and then I am going to turn on the benchmark, and so the fans ramp up, and I want you to see the difference. Okay, so what we can do is let's try with CPU Z stress CPU. Okay, as you can see, when I'm not talking, it's like 46. Okay, so now I am going to start and see how it does. Okay, you get the point. So it's very quiet, honestly. You can't really hear much. If you put this behind your monitor, you can forget about it. You will not hear anything out of it. So that being said, CPU only. Now I'm going to load a bunch of games, Batman and the Doom Eternal, and then we are going to see how it does with CPU only. We'll try eGPU later, but I just want to try the CPU only. So give me a couple of minutes, let me set it up. Okay, so we are in Batman Arkham Knights. This is on the high, almost everything on high, and we are at the full screen, which is 1600 by 900. This one, let's not cap it. Okay, and high, and these are the settings. Okay, so with that being said, as you can see, we are in the game with high preset, and we are getting 50 FPS, and the power consumption is almost capped. This is like 80 watt, very close to the max. As you can see right there, GPU is 98%, CPU is 7, but yeah, this is very playable. This looks great and working fine. So yeah, we are getting 50 FPS with absolutely no trouble. 64 sometimes, yeah. So it goes up and down, and you can see GPU consumption. Yeah, this is 88 now, as you can see. So you can tell that with high preset, we can easily play this game. I know this is not really modern, it's not recent, but I just wanted to show you guys that this game plays absolutely fine with no GPU. That's just one example. Let's try another game. All right, so we are in Doom Eternal, and this is the resolution, 1280 by 1024, and it's full screen, and we are kind of on high preset on this. Yeah, everything is on high, as you can see. Now we are going to go back to the game. As you can see, the screen is not really full screen. You saw the resolution, but yeah, this is what we are getting, 47 FPS. very smooth to play, I would say. And yeah, this is what you're seeing. 45, 47. Power consumption, by the way, 85, 86, capping it kind of. Okay, so we are doing great over here, 46, 47, and those are 98% of the CPU consumption. Okay, so you can see that's what we are getting. That's also for Doom Eternal on high with that resolution. So you get the idea. On its own, with no external GPU, you see what it can do, right? And now it's time for me to bring out this bad boy, which is the AMD 7600, I believe, right? 7600M XT. So what I'm going to do is I am going to basically hot plug this in there. That is inserted. And now I am going to plug that in, not going to add it to the power consumption. So not connected here. Okay, so we are still just seeing the power consumption of the main computer alone. So now I'm going to turn it on and let's see how it goes. Okay, so some tweaking later. I have the GPU connected. Actually, it was the driver issue, nothing special. I didn't even reboot, just the driver. Let's go to the settings. I just want to show you, we are in Ray Tracing Ultra and it already detected the AMD GPU, and you can see the resolution and everything is on high, okay? High and ultras, okay, all around. Very, very, smooth should be the video. And as you can see, we are getting 40 frames per second using this, and you can see the GPU and CPU and everything. The power consumption you're seeing is just the main computer, and we are connected, as you can see, only using the OCuLink. This is it. This is the resolution, as you can see, and very smooth. We are playing very, very smoothly on ultra ray tracing, basically, and it's working. The OCuLink is working perfectly. There is absolutely no problem, and we are getting 38, 39, 40, 41, yeah, around that range. 38 minimum and 41 max I've seen. I don't think I ever saw 42, but yeah, here you go. You can see it's extremely smooth. Yeah, so I just wanted to show you guys that the eGPU through the OCuLink is also working in Windows 11. So yeah, we are pretty much done with the graphics and the gaming and the performance. Now it's time for what power users like to see, Linux and Proxmox. So what I'm gonna do is I'm gonna swap the NVMe SSD and we take it from there. The loud fan, I don't know if it comes across through the speakers, is this bad boy. This is completely silent, and we'll do some more tests when I'm doing like benchmark and Linux. All right, give me a couple of minutes. Let me swap up the NVMe SSD. Okay, so we are in Ubuntu. As you can see, Ubuntu 24. Its CPU is detected over here. Intel Alder Lake is over there. Okay, the GPU is detected. Everything is detected and working perfectly. So what I am going to do, and you can see the CPU temperatures and everything on the right side, and that's going to stay there for a while. I just want to quickly test the 2.5 gigabit Ethernet speeds, and as you can see, it is 2.5 gigabit. You guys told me, and I've seen it on some other forums as well, it's better to do the iPerf test in Linux. Anyway, that being said, let's try this stress NG test very quickly. So we are doing this test almost on every mini computer and SBCI test on this channel. 30 seconds of matrix prod, and as you can see, the power consumption went up to 82 watts, and you can see the temperatures and everything right on the screen. CPU usage is 100%. That's kind of capped. So let's see how it goes. Okay, so the test is done and we are getting 500,000, 550,000 almost, and BOGO ops per second, oh my god, it's 18,172. Just for reference, here, BOGO ops total, not BOGO ops per second, BOGO ops total for 30 seconds of the very same test on Raspberry Pi 5 is 870. So 870, and this is getting 18,172 per second. Terrible comparison, I understand. I just wanted to give you a reference. It's a lot. It's very fast. 500,000 BOGO ops is a lot. The higher numbers that I saw on this channel, like 2 million, was when I was building those Xeon giant servers, or when I did the AMD server build, the dual CPU, okay? But other than that, usually this is very high. I don't think I've seen this high in a mini computer. It's very good. So that being said, let's try the Ollama. And I have a bunch of models. I think the 70B is gonna be too much. Let's go one below that, which is the 32B. So Olamaran DeepSeek R1 32B verbose. So let's do that and keep an eye on the power consumption. So this should go up to like 80 when I actually enter something in the prompt. So let's wait. Okay, I'm going to ask the same question I usually ask again. Okay, there you go. Off the races. So it's my eyes got trained on the detecting the tokens per second in this. So I'm going to roughly estimate this as 2 tokens a second. I would say 1.5, 2 tokens per second. So let's fast forward and see how we're doing. And by the way, this is the first time I'm seeing that 104 watts. I did all sorts of benchmarks in Linux, in Windows. I never see this. First time I'm seeing anything above 90. The max number I saw here was 90. Somehow this is going to 105. Okay, actually I take that back. That's not 2 tokens a second. That's like 3.2, 3.5 tokens a second. Let's fast forward and see how it does. Well, okay, I was off. It's actually 4.88, so call that 5 tokens a second, not 3. So as you can see, the model we ran was DeepSeek R132B, and we got 5 tokens a second. Very impressive, and it was using 100 watts. Just to be clear, EMID code 17. So yeah, I inserted a 32 gigabyte per slot DDR4, and it's a 2666 MT basically, okay? And 32 gigabyte RAMs. It's 64 gigabyte RAM, and that's the performance we are getting out of it. 5 tokens a second on the 32B model. Okay, yeah, so there you have it. That's also very acceptable, very good performance for LLMs. So the last thing I want to show you guys is confirming and getting Proxmox to work. So give me a couple of minutes, I will be right back. Okay, so I swapped with the Proxmox, as you can see on the screen, 172.16.14, and let's go to my computer. And as you can see, we have this i9 12900 HK. Okay, I just want you to see how long it takes to basically boot a container. 1, 2, that's it. Once you boot, and you can see how fast everything is. Okay, so I just started an Ubuntu container, and I'm going to let it rip as it is upgrading a lot of packages, 60 something packages. Let's start an Ubuntu desktop in this case, and I just want you to also see how long it takes to boot. And the boot started now for Ubuntu desktop basically. 1, 2, 3, you see? So it's fast. That's all I want to say. Once you're in, as you can see, it's very snappy. By the way, you can see power consumption is like 20-30 watts when it's idle. And now let's not idle. What idle? I actually have 1 container and 1 Ubuntu desktop running. That's the power consumption. All right, so now let's add another one, which is going to be Windows 11, and I want you to see the speed. Start from here basically, 1, 2, 3, whatever. So like 10 seconds, there you go. Now it's up to 90 watts. Yeah, here what we have is basically 90 watts. Windows 11 is running, and it is snappy, by the way. If you see some delay, it's graphical stuff, right? The interface, yeah, but you can see it's very easy to use, very smooth to use. You can run numerous containers. I can tell you with this CPU, which we have like a 20, yeah, so we can easily run, I'm gonna say 15 containers or like virtual machines like the Ubuntu desktop or Ubuntu server with no problem, with no hassle. So as you can see here, I can come here, search something, go back over to the Windows 11, search something. Yeah, it's fast and very snappy. I just wanted to show you guys that this is also working, and we are not really doing a lot server load. You know, we're not even putting any dent in the CPU or the memory. Okay, I have 64 gigabyte memory, and we are here in the usage, and I have a i9 12900 CPU, and we are here, like we ran all those tests, we're just like 1% or something like that. So I just wanted to show you guys that the Proxmox also works perfectly. I did not tweak anything, and everything out of box started to work. So one thing I forgot, it didn't go in order. So one thing I forgot is I always in my videos show you guys also the BIOS, but this is like a typical MinisForum BIOS. That being said, let's let's go back to this. I'm going to reboot and then show you guys the BIOS. So I am rebooting, and now once it's back, I'm going to show you guys the BIOS. You're familiar with this if you've used any MinisForum device. Yeah, this is pretty standard. This is the BIOS, everything else. And let's go to the advanced section. Trusted computing is there, obviously. We booted into Windows 11, and these are the hyper-threading, turbo performance. I didn't touch it, by the way. This was how it was. And the C states, turbo mode, all efficient cores, active efficient cores. So all of them are there. Security and boot, basically. Let's keep going. Onboard device settings. These are the internal graphics you can enable, disable. And controller, PCI, yeah, resize bar. I know you guys keep asking me in the comments. The resize bar is there. Above 4G decoding is there. SRIOV is there. So with Proxmox, you can do, I guess, like splitting GPU and other stuff if you can get it to work. But yeah, IOMMU, all that stuff is right there. ACPI settings, wake up on LAN, wake up by RTC, all that stuff. Hardware monitor, you can see the temperatures right there. We are coming back from the benchmarks and tests. So yeah, deep S5 is there, but it's not enabled by default. If you need it, you can enable it. And the network stack configuration, that's it. I think we pretty much covered everything about this mini computer. I believe this goes like with the 1 terabyte and 32 gigabyte RAM goes for, I believe, something around 600. I will put the link below. You can order this from Amazon if you want to, or from MinisForum website directly. But yeah, this is very lightweight, very powerful computer, and it is very quiet. The fans, only when it ramps up, like when I was doing the Llama, it's not much. It's probably around like 7-8 decibels. But when it's booting, I can show you. So I'm just going to connect the power. Okay, so when it initially starts, the fans ramp up. So I just want to show you guys how it is. So first I'm going to turn it on and stop talking and see how the baseline is. Okay, so baseline is like 48. Now I'm going to start this and just hear the fans when it ramps up, okay? So there you have it. It is very, very quiet. It won't bother you. That's what I want to say. Yeah, you can absolutely use this for various tasks and projects. You can throw multiple servers at it, like in Proxmox, run, I guess, I don't know, 7, 8, 9, 10 servers on this. It will handle it with no trouble. You have 2 gigabits, so you can even use one of them for Proxmox. The other one can be one of the guest ones. Let's say you want to run a TrueNAS or something like that, or pfSense or something. You can run a Nginx proxy on this. You can run workstation, Windows 11, as you saw there. Even with external GPU, it was playing games perfectly fine. Yeah, so very powerful device. I wasn't really expecting it to be this lightweight, honestly. So very lightweight, very powerful. Hope you guys enjoyed this video. Please let me know if you have any questions, and thanks for watching. I will see you guys in the next video. Bye for now.